Hello, good afternoon.
Good afternoon, sir.
Yeah. So today we'll just go through the sample programs and we'll see one or two lab programs also, because next 2 weeks you missed. There was no lab sessions for you people. So next week onwards the labs will start. So you should have something to do in the lab. A few sample programs and one or two lab programs should be there with you people. This sample program was done in the previous class. I guess you remember this?
So
Yes, sir.
Yeah. So this is the program to load the data from memory to the register. Okay. So what is the meaning of this? What is the meaning of this? LDR R1 comma.
R1, what is the address of
Correct. So you're loading the address of the memory location value to the register R1, and then uh, here in the next statement you're loading the content uh, of the memory location whose address is present inside the register R1 to R2. If you write something inside the big bracket, it will take the content. Now R1 has the address of some memory location. Now this is going to take the content of that memory location and load it into the register R2, and then we from R2 again we moved it to the register R3, and this was, and now this data which was declared here, it was within the what code segment itself. So this is end here, and this is the code area, and I've called it as ones. Okay. So and this data what I've defined here, it is living inside the code area itself. Now in the second program, okay, so earlier I've given you two programs. One is for addition and subtraction. You can keep them as the sample programs, and this is another sample program. I guess all of you have written this. Have you noted this?
Yes, sir.
Okay. Now program to find one's complement. Okay. I guess all of you know what is one's complement is. Say for example, if I write 4 ones, 1 1 1, one's complement of that is 4 zeros. Okay. And similarly, if I write 0 0 1 1, and one's complement of that is 1 1 0 0. Okay. So you just go for inverting the zeros to ones and ones to zeros. So this is the program for doing that. Now again, so in this you can just observe, this is my code area till here. Till here it is my code area, and after this I'm defining another area, separate area, so which is I'm giving the name as the data, and this is the data area. So this is your assembler directive. Okay, and here code is again an assembler directive. It's saying from here till here it is the code area, and from here till here it is the data area. And the data area, so the area which you name as using the assembler directive data is the data area, and it can be both read and written. So but this area it can only be read till here, whatever you declare, and from the memory location it can only be read, but it cannot write it. So, okay, we'll see what's happening over here. So as usual, as we went through the program in the previous class program, so this program, so what we're doing here, I'm just trying to load the put the address of the memory location value to the register R1. Okay, and right now if you look here, so the value is here, and DCD I've taken it as 0. So I'm not writing any data over there. So intentionally I've taken it as 0. And next, what I'm doing, the content of that memory location. Okay, so 0 0, if you write, how many bit it is, sorry, how many byte it is? Only 2 zeros are there. How many byte it is? 1 byte. Correct, right? So but when you're loading this 1 byte of data to the register R2, now it gets sign extended. That is what I explained yesterday. Yes or no? It gets sign extended to 32 bits. Okay, so first I load the address where this value 00 is stored to the register R1, and then I'm moving the content. I'm loading the content of the memory location whose address is present in R1 register to R2. Now R2 gets the sign extended value of this. So here it is only a byte, but here what R2 gets filled is filled in with the 32 byte data, sorry, 32 bit data. Okay, but still the value is 0 itself. And next, now I have this value in the register R2, that is 0. Now I need to complement it. I need to find the ones complement. So MOVN, MVN is there. Now what move negate it is. Okay. So what it will do, it will take the value that is present inside the register R2 and then it will negate it. It will do the ones complement and then it will put it to R3. Now in R2, what you'll be seeing? What will be the value in R2? So let me write here. R2 gets this value 0x. How many zeros? How many zeros? How many zeros?
8 zeros.
8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and this 80 in binary is nothing but what? So for this 0, I have to write how many zeros? 4 zeros. And for the next 0, how many zeros? 4 more. And for this 0, third 0, again 4 more zeros. Okay, and for this 0, fourth 0, again 4 more zeros. And for fifth 0, again 4 more zeros. And sixth 0, 4 more. And the seventh 0, it is 4 more again. And eighth 0, it is 4 more again. Okay, so this is a 32-bit 0. Okay, now when I do this MVN R3 comma R2, this is what is there in R2. Okay, this is what is there in R2. Now this gets complemented. So let me write now 0x. Can you just tell me what is the ones complement of this? Yes. What is the ones complement of this? What is ones complement of this?
1 1.
No, it is not 1 1 1. Observe here. See here. So this is in hexa and this is in binary. Now every bit will change from 0 to 1. Yes or no? 1, 1, 1, 1, 1, 1, 1, 1, and then 1, 1. Sorry, 1, 1, 1, 1, 1. This is nothing but what? This 1, 1, 1 is nothing but what? F it is. F, 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 and F. How many Fs? You get 8 Fs. Hope you people understood. Is that clear?
Yes, sir.
Yeah. Yes, sir. And then see intentionally, that's what intentionally we have taken the data as what? 0, because I just want the result to be all 8 Fs. Okay, so taken intentionally the value as 0. I load the address of the value to register R1 and from that I load the value 0 to the register R2. This 0 is the content of this memory location, and then using MVN I'm moving the ones complement of the value which is there in R2 to the register R3. Okay, so this is what you should see in R3. And finally, I don't want this in the register. Okay, in the R3. So I need it in the memory location. What I do now, again, say I've created one more memory location result in where, in which area, data area. Now this memory location can be written. So this memory location can only be read. So you can read this 0, but you cannot write this. This memory location cannot be written. Since this memory location result is created inside the data area, it can be both read and written. Now what I'm doing, I'm loading the address of the data area, sorry, this memory location result to the register R1, same as we did here. Now the address of this memory location result gets loaded to the register R1. Now, where is the data? My result. This result is available where? It is available in register R3. From R3, I need to store it to the memory location. Which instruction I have to use? Store. Hope people are following. Hello?
Yes, sir.
Yes, sir.
Yeah. Store is the instruction. You have to respond first. Okay. Store is the instruction. Now what it will do? It will take the content of register R3 where you have the result and it stores it to the memory location whose address is present in the register R1. So don't confuse here. When it is load, so this is your source. This is your source and this is your destination. For store, it is opposite. For store instruction, this is your source and this is the destination. From here, the data goes to this. For load, from here, the data goes to this. Hope you understood. Is it clear?
Sir.
Yes, sir.
Yes, sir.
Okay. Now we'll go for executing this program. Okay. Okay. Let me close this project. Okay, I have too many windows open. Let me close all of them. Okay, and this I'll minimize. So this also I'm closing. So this also I'm closing. Okay. So now you start writing along with me. Take your observation copy. So make this a sample 1, 2, 3, and this is a 4th sample program. Okay. Now I'm closing this project and opening a new microvision project. So let me go here and create a new folder. So let me call it as sample 4. Project name also I'll give it as sample 4. Say next, save, and now I'll choose a target device LPC2148. Select this and click OK. Startup.s is not required. So now file new. Okay, before writing, I save this. Now I'm saving it inside the sample 4. Let me give it as sample 4 itself .s. Now the extension is .s. So done. Now we'll go for writing the program. So let me write the comment statement. So program to find one's complement. All of you can see my screen.
Yes.
Yes.
Sir.
Yeah, and you're able to make out the font size is okay, right? Or do I need to increase it?
Okay, sir.
Okay. Just see. Customize. So else I can use magnifier. Let me try that once. Is this fine?
Yes, sir.
Okay.
Yes, sir.
Okay. So now we'll start writing. Area. So let me give the name of the program as once. Okay, the name of the area what I'm giving is once, comma, and it is code, comma, and what it is, read only. Fine, right? Correct?
Yes, sir.
Okay, next. So move, sorry, not move, LDR R0, comma, equal to value. Okay, next. LDR So this is what I'm getting the address of the memory location value to the register R0. Now R1, comma. So what is that I need to write now? So tell me.
Content of R0.
Content of R0. Very good. Content of R0. Next. I need to find one's complement, right? MVN is the instruction. R2, comma R3. Sorry, R1. I just take the ones complement of R1 and then I move it to the register R2. Next. Now I don't want this ones complemented value in the register R2. I need to store it to the memory location. Yes or no? Now for storing it into the memory location, again I need to get the address of the memory location. LDR what? So you can take any register. Let us take R0 itself now. R0. So because I can reuse it again, because R0 content we have already loaded into the R1 and R1 is once complemented and already the result is written to R0. Now I can go for reusing what R0. R0 comma, so equal to result. So let me give one more memory location name as result. Next. Now in R0 you have the address of the memory location result. Next what I have to do? I have to make use of store instruction str and the content which is available in R2 I need to move store it into the memory location whose address is present in which register?
R0.
R0. Good. Okay, next what I'll do, so I'll go for writing this back b back, and then I need to define my value. Okay, value. Okay, DCD as 0x00. We are taking it as 0. Okay, and next, sorry, value VALUE. Okay, next. I need to define one more area. Now this is from here till here, it is my what area? Code area. Okay. Now I need to define the data area now. Okay. Area. Let me call it as what will give. Let me give the name of the area as RES. Okay. So RES is the name what I'm giving. And what area is this? This is not the code area, data area. And then it is read, write. Inside this, I define result DCD, and you have to store something. What will store that? 0x00, and then finally I write end. Hope you understood. It's the same program which I showed you in the notepad. All of you copied this?
Yes,
Yes,
sir.
sir.
Okay. Now I'll save this again. Now what we need to do now, we need to add this to our target device. To add this to the target device, I right click on this, add existing file to the source group 1. Now here I go to search for, let me remove the zoom. So search for .s program. So this is my .s file. So you can see here .s file. I'm adding it. Then close. Now if I expand this, see sample4.s is added. Now I go for translating. Now let me zoom. I think it's difficult now. Okay, it's okay because program I've already written. I can see here 0 errors and 0 warnings. Next I build. Okay, done. Now I go for debugging. Okay. adjust the frames appropriately so that you can clearly visualize all the registers. Okay. So even I don't know, okay, what is the address where this 00 is stored inside the memory. Okay, once the statement gets executed, you'll get that address in register R0. Let me wait for it. Okay, let me press F11. Okay, I'm pressing F11. See now, in register R0, what is that you have? 000018. So this is the address of this particular memory location, and what we have there, we have 0 stored. Okay, let me go. I'll just show you that in the memory location. Now the memory window is not right now there. So to get the memory window, so you can go here also. So this icon, if you can see here, or if you can see this, observe my mouse movement here. Click here. So you can add 4 memory windows, and 1 memory window is enough for us. So I can click on this and I can add the memory window. Okay, or otherwise you can go to view and the memory windows, memory 1, 2, 3, 4. It's here also. Okay, so you can choose either from here or from here. Let me click here. Okay, it came. So this is the memory window. Let me position it appropriately. Okay, all of you can see this, right?
Yes, so.
Okay, now I'll put this address here. You have to start with 0x. How many zeros? 6 zeros. 1, 2, 3, 4, 5, 6 zeros and 1, 8. So press enter. Okay, so this is your data. What is that we have stored? 0. Okay, this is my data. My 0 is stored here. Okay, let me proceed now. Now LDR R1 comma content of, say this is memory location 000018. Okay, so when I'm here it is stored. So let me proceed and move the content of the memory location whose address is present in R0 to R1. Now what R1 should get now? 0. So I press F11 because the content of this memory location is 0 and it gets sign extended. Okay, see R1 is 0. R1 is 0. Next. Now what we are doing? So I'm trying to find the complement of R1 and once complement of R1. So you can, if you just drag the mouse on R1, you can see what is its result is. Okay. Now if I press F7, F11 now, see what is there in R2, or just drag the mouse on R2 here, you can see FFF. So this is what you got now, FFF. So once complement is obtained. Hope you understood.
Yes, so.
Okay, next. Now this, okay, result is available in R2. I don't want this here in the register. I want it inside the memory location. I need to push this to the memory location. So first I need to get the address of result. Okay, so LDR R0 comma result, address of this particular memory location. Now remember always for the data section. Okay, so the data area always starts from the address. Let me write here 4 followed by 7 zeros. 1, 2, 1, 2, 3, 4, 5, 6, 7. So from this address, your data area starts always. That means your code area will be there from 0, 0, 0, 0, 0, 8 zeros to 3 F, 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 F. So this is the last address of your code. Okay, that means you can, your code can start from 0, 0, 0 and it can all the way occupy the memory locations till 3 FFF, and your data section starts always from 4 followed by 7 zeros. And this you always keep in mind. Understood, right? Response is required.
Yes, so.
Yes, sir.
Okay, now say what is that you expect in R0 now? So when this statement gets executed, after this statement gets executed, what is that you expect in R0? Yes.
Address of result.
Address of the result.
Address. What is that address is? What is that address is? Just now I told. It is
4
this
followed
address.
by.
Yeah, 4 followed by 7 zeros. So why? Because so we've declared this result inside the data area. Inside the data area. Okay. Now observe now I'm pressing F11. See what is this value is 4 followed by 7 zeros. 4 followed. So that is there in register R0. Now what is that I'm trying to do? I'm trying to store the content of register R2, okay, content of register R2 to this particular memory location, the memory location whose address is present in R0. Now in R0 you have 4 followed by 7 zeros, okay, any number, okay. So any variable or any thing which you declare inside the data area, it always starts from 4 followed by 7 zeros, okay. Now so let me do this. So let me go to this address first. Okay, I'm coming here. I'm removing this 0x 4 followed by 7 zeros. I'm writing. Erdu naku idu. Idu aru idu. Okay. See, this is the address. 4 followed by 7 zeros. And what is stored here right now? 0. Okay. Now, the moment this statement gets executed, so the value which is present inside the register R2 gets stored here. So that is this will change to FFFF. I'll show you. I'm pressing F11 now. Observe. I pressed F11. You can see you have FFFF stored to the memory location 4 followed by 7 zeros. So this byte address is 4 followed by 7 zeros, and this byte address is 4 followed by 6 zeros and a 1. This is 40000001. So this is 1. And this is 4 followed by 6 zeros and 2, and this is 4 followed by 6 zeros and a 3, and this is 4 followed by 6 zeros and a 4. Hope you understood. Is it clear? Hello?
Yes, sir.
Yeah. So this is what the data is. So what we have done now, we have written this data to the data area, and which can be both read and written. So you can read this also. You can, this memory location can be read, and if you want to, if I want to overwrite this, say I don't want it as FFF and all 4 Fs. Say this is I need FF, and this I want to change it to 00. I can update. So, but the same thing is not possible if the data is present inside the code area. Code area is only read only. That means from the address 0000 to till 3FFFF. So you can only read, but you cannot write. Now, if you want to write something and repeatedly update some values, then it should be there declared inside the data area. Okay. So, okay. So with this, let us move on to the next one. So all of you copied this program, right? So if you copied, we'll move on to the another program.
Yes, sir.
Okay. Now the next program. So now you got 4 sample programs. So one addition, one subtraction, and one program is this. Third program is this. Okay. Third program is this, and this is the fourth program, where you understood how to create the data area also. Okay. Now we'll go to our first lab program, and it's very simple program, and let us finish that. And even though it is a simple program, there are few things to understand. Let me show you. Okay, this one. So copy this. So this is not a sample program. I have a few other sample programs also. So let me give them later. So now you copy this. Write a program to multiply two 16-bit binary numbers. Copy this. I guess all of you have the observation copies with you.
Yes, sir.
So write a program to multiply two 16-bit binary numbers. Okay. Now, so I guess all of you copied this. Is it done?
Yes.
Okay. So now we'll, yeah. Let me save this, close this project and open. Oh, this is still under debug. Let me stop. Project close. Project. Okay, let me close here. It's already there. Let me open. So the name of the program is this multiply 16-bit numbers. Okay. So I've stored here in this. Now, if I want to launch from here directly from the folder, this is my project file. I need to double click on my project file. Okay, I'm double clicking on this. Okay, so this is the program. Okay, see, it says the question says two 16-bit numbers. Move R1 comma 6400. This is what I'm giving, and it's a 16-bit number. So this is a byte of data. This is another byte. Byte plus byte is 2 bytes. 2 bytes is nothing but 16-bit. And then to R2, I'm moving this 3200. So this is one 16-bit number. This is another, sorry, this is an 8-bit number, and this is another 8-bit number. 8 plus 8 is 32, 16. Okay, and then I'm multiplying and storing the result into the register R3. Okay, so very simple program. So please copy this. Please copy this. And you all know how to open the project, how to add everything. So if you want, I can recreate this once again. Okay. So 6400 and 3200 is the two 16-bit numbers which we are trying to multiply. Okay. So let me close this and try to create a new project. So project, new microvision project. So let me, inside ARM samples, let me create one more folder. Okay, or otherwise, let me come back. I'm on the desktop. Here I create one more folder with the name ARM lab programs. It's a new folder ARM lab PGMS. Okay, I'm opening this, and inside this I'm creating. So let me, this is since it's a lab program 1. Okay, lab 1. Let me give the name of the project itself is lab 1. Save LPC2148. Okay, startup.sh is not required. Go to file, new. Okay, so let me write the title of the program. Program to add, sorry, multiply two TW 16-bit numbers. Okay, now area. Okay, let me save it first. So I'll give the name of the program also as lab1.s. area. So let me give lab1 as the name of the area, comma code, comma read only. read only. Now move R0 comma, we will do this 6400 and move R1 comma 3200. Now multiply R2 comma R0 comma R1 and back B back. So this much. Done, right?
Yes, sir.
Okay. So remove zoom. Now save it. Add it to the source group. Okay. So now we'll go for debugging. Sorry, translating. 0 errors and 0 warnings. Build. Now debug. Okay. So before that, before proceeding with the execution, so let us try to multiply. Try to multiply these two numbers what we have taken 6400 3200. Now this is decimal numbers what I've written. So but see hexadecimal equivalent of this 6400 is what? See if I just move the mouse over it, it will show me. It is showing me. It is 1900 and the hexadecimal equivalent for this 3200 is C80. So let us go for multiplying. I have the calculator open here. So let me clear. Okay. So this is I'm in the programmer mode. So this is what the standard view. This is what the scientific view. I'm in the programmer mode right now. I've chosen the hexadecimal. Okay, I've chosen hexadecimal. So now this is already showing me. Okay, the hexadecimal equivalent for 6400 is 1900. Okay, and these zeros are not necessary for us. These zeros which are towards the left side, so we'll ignore. So 1900 into and the hexadecimal equivalent for this 3200 is C80. Okay, C80 is equal to, this is what I need to get. The product is this 1388000. Okay, now I'm pressing F11 now. See here you have hexadecimal equivalent of the 6400 moved to the register R0, that is 1900, and then C80 to the register R1. So now you're multiplying. Okay, it is 1388000. So what we got here? So 1388000. Okay, this is, and then back B back. So it stops here only. Okay, next. So when you're writing multiply instruction, okay, so can you make both? See, normally in addition, okay, don't copy this. Say I'm adding, I write something like this, R0, comma, R0, comma, R1. Now what is the meaning here? So this R0 is acting as source and after addition it acts as the destination. Now can I write something like that here? Say I'm trying to multiply R0 into R1 and can I make the destination register also as R0? Not possible. So this is not possible. In multiply instruction you cannot do that. Why you cannot do that? You'll understand. So when we go to the module 2, so there I'll clearly explain you. Okay. So why it should not be the source, okay, should not be same as, so the destination register should not be same as your first source register, remember. So can you write here the register which is the first source is, can I write r1 comma r0 comma r1, that is allowed. So you can make your second source register as the destination register, but you cannot make the first source register as the destination register. But in addition instruction, either you can go for making your first source register or the second source register itself as the destination register. And why? There is a reason for all these things. Those things you'll understand when we go to the module 2. But right now, so this is enough, I guess. Got the point? So this is not possible. This is not possible. So can I write something like this? Yes, it is possible. So now we are using a totally different register R2. Is that fine? You understood it? No response.
Yes, sir.
Yes, sir.
Yeah. See, you in multiply instruction, the first source register cannot be used as the destination register. Okay, first source register cannot be used as the destination register. So that's the reason I've taken a completely new register with the name R2. So this is the lab program. Okay, next. And so there is one more restriction also here. So that I'll be telling again when I go to the module 2. Okay, when you're moving, you know, so it's not like you can move all the numbers. So there is a constraint. So there is a constraint. I'll highlight that. So if I want to move any number, first you should get that number into the memory location, store that inside the memory location, get the address of that memory location, and then you can load. Okay. So for example, let me, what shall I take? So I had an example. I have one slide in my module 2 PPTs. So right now, so you keep in mind that all the numbers cannot be moved directly, you know, like this to the register. There is a restriction again. So only those numbers which can be represented by using 1-bit circular left shift, and there is some operation. So only such numbers can be directly moved to the register. So the numbers which cannot be represented in that format. So what you got to do is you got to store them into the memory location, and then using LDR R0 comma equal to the name of the memory location. You have to get the address of that particular memory location and load the content to the register using again LDR. So as we did in the previous program here. So this is what you got to do. So this way it is possible for you to load any values into the register. So but using this way, there is a limitation. There is a limitation and there is a restriction. And what is that restriction? At this point of time, it is not necessary for you. So I'll highlight when I go to the module 2, and when I'm explaining in the module 2, so again I want you people to revisit this program and try giving the different values, and you got to observe, and if I'm the examiner, I'll be asking definitely the questions, you know, why are you moving 6400? So take a different number and move it. So I give the number so which you cannot move directly using the move instruction to the register. So then your program will not work. So that time you got to justify. You got to justify. So this is the reason, and moving this number is not possible, and this is the limitation of the move instruction. So if you want me to perform the multiplication of this number, then I need to store this into the memory location, and from the memory location I need to get it to the register. So this is what the proper justification you got to give. So I'll give you all those statements when I'm explaining in the module 2. So done, right? Is that fine?
Yes, sir.
Yes. Okay. And this program looks simple, but I've already told you the questions that can be asked on this. Okay. Just a second. Okay. So we'll take up this also. Write a program to find the sum of first 10 integer numbers. Find the sum of first 10 integer numbers, that is from 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. So this is what the sum you got to find. Okay, so take down this question. Copied it?
Yes, sir.
Okay. Now I'll close this. I think 64 is, it'll give error. I'll just show you. Okay, this is fine. It'll take this. Yeah, so this cannot be. Say I gave 6666 and it's an error. Immediate, and this is the hexadecimal equivalent for this 666. It says cannot be represented by 0 to 255 and a rotation. Now what move can do is move instruction can move only those instructions which can be represented by 0 to 255 and a rotation. Now and in depth you'll understand when we go to the module 2. So because I at this point of time I don't want to disturb you people by taking all those concepts here. Okay. So this is not possible. Now in case if I want to multiply this number itself, then what are the changes I got to do? What are the changes I got to do? So I got to declare here, sorry, not here. Value, I'm just showing you, that's all. Value DCD 0, sorry, it is this number I need to take directly 666. Now what we got to do here, let me comment this. So yeah, can you just tell me what is that I need to do? Please.
LDR, RO.
Yeah, LDR, good. R0, comma.
Equals value.
Yeah, equals value. So first store it into the memory location, and from the memory location you can get it. LDR R1. Okay, I need to change the registers. Okay, I can do that. R0. Then here let me take it to R2 because this can be moved. Okay, and here I have the numbers and now R1 and R2. Let me make this as R1. This is R2 and this let me make it as, so R2 also works. So I said you cannot make first source as the destination, but second source can be made as the destination, but let us not do that. So I'll take R3. So now this works. Okay, so please make a note of this. Please make a note. So you write the normal program. So without these two, okay, just write the normal program. Okay, so the one which was earlier, and just below that you write this as well. Write this as well. So copy this before we go to the second program. Copy this. And this is the error code. So this what you are seeing here, A1 A15110E is the error code. Error code for this limitation. Okay. Now why this limitation and all we'll discuss in the module 2. Done. So please inform me after you done with copying. Finished?
Yes, sir.
Okay. So what is the time? So 128 it is. Okay. So I think enough. For the next week, we can do this, the 4 sample programs and this lab program. Tomorrow, My class is not there. Monday, we'll first half an hour we'll go with the PPT, and the second half I'll try to give you the second lab program. Okay, because that is also a simple program. The second lab program which I showed you here, there's write a program to find the sum of first 10 integer numbers. So we're going to write a looping construct and then find the sum from 0 to 9. Okay, so easy. We'll do that in the Monday's class. And as of now, please copy both the things. So the original one which I gave and this also. Okay, if the examiner asks you multiply, say 666 with 666, so then both the numbers you have to store inside the memory location and then you should get into the register. Okay, so all these things. Okay, we'll stop here. We'll download. Any doubts? If you have, you can ask me. Any doubts? Except that restriction. Why that restriction is there in the move instruction? So that you'll understand in the module 2. So apart from that, if you have any other doubts, please let me know. Okay, you people will not answer. Let me call randomly. My technique. USN 043. Please unmute.
Yes, sir.
Yeah, what's the name?
Chetas.
Chetan, you understood, man?
Yes, sir.
You understood the program. Okay. Divin R. Divin, I guess diploma student. No. Divin, please unmute. I don't know. He's not responding. 82 082 082 095 095.
Yes, sir.
Yeah, what's the name?
Nakul, sir.
Nakul, did you understand?
Yes, sir.
The pro. Okay. Okay. Anushri, unmute.
Yes, sir.
Yeah, did you understand?
Yes, sir.
Okay. Any doubts? Yeah.
No, sir.
Okay. Next is last one. Swanson. Swanson. Unmute, man. See, I don't want this response. See, when I call, if you're not responding, what does it mean? You are just connected and you're not listening to me. So Swazan, I think 2 or 3 names which I called, they're not responding. They're simply connected. Huh? So what is the use? So Divin says mic is not working. Okay, no problem. But Swazan is not responding. So I guess is sleeping. Is connected to the meeting and sleeping. I don't know what he'll achieve with this. Okay, see, Swasan is not responding. If any of the his friends are there, please inform him about this. Okay. Okay, let me call someone from here. 25 025.
Yes, sir.
Yeah, what's her name?
Anusha.
Anusha. Okay, so sorry. See, I got to do this. So I know Many of you are attentive and listening, but still I got to do this just for my satisfaction. You understood, Anusha?
Yes, sir.
Okay, thank you. Okay, let me download the attendance. Okay, then thank you. We'll meet again on Monday.